Yeah, no worries. Um, all right, let me pull up the agenda for today. Lorenz, do you want to kick it off? I saw that was some new status on your donation.
Yeah, so that's the only stuff I could actually work on. I think it's in the final stages now, at least from a permission point of view. So I guess I'm not sure if you know how many votes I need to get accepted, uh, or if you just wait for some amount of time and see if there are more upvotes than downvotes.
It's gonna be a time. There's gonna be an end for it, and unless there is anyone disagreeing, it's not gonna be a problem.
Okay,
Um,
so saw something there. Um,
so yeah, you can. I don't know if you told Lucas to just uh, go on with the donation, so he can ping TSC members.
I actually pinged already everyone, like in this ticket here. Let me copy this to the chat. So we open the vote, and the vote says it stays open 28 days. Not sure if you have to wait now 28 days.
That's probably how it works. Yeah.
Okay, it will pass if at least 51% say yes. Okay, I guess then we have to wait some time. Maybe I can already have a look how this works technically after I get accepted. If we can transfer the repository or if we have to create a new one. There's some bullets to it.
Yeah, I think Lucas will reach out how that's gonna play out. Wasn't possible to see the vote status? I can't remember. Mm, hmm. Yeah, I guess that's how it's gonna work. I thought 28 days was a bit long, but might just be standard. Okay. I haven't really had a chance to do any progress since last time. Um, but since you are here, Lorenz, I could show you something. Let me just find it real quick. Let me see if I can share my screen. Okay. Hmm. So before we will let go from Postman, me and Suvik worked on how we could use the JSON schema files that we have as a single source of truth for parsers. So we wanted to see how far we could generate most of the code for a parser. So our approach was to use the, let me see if I can move this screen, was to see if we could use the Modelina tool to generate, like, just take the JSON schema files that we have, the official ones, and then use Modelina to generate the parser code, basically, or at least a lot of it. And we ended up actually having something that is kind of working. So we basically generated for all the versions, and everything that is generated is very, very basic. Like, it's just a one-to-one representation of the data structure of the async API document. And the only thing that we had to customize is, for example, traits. We had to implement like traits functionality so it can be applied. It can't really be auto-generated that way. Validation functionality, like taking those JSON schema documents and then also validating it as you're parsing it. And then, of course, the generic parser functions with parser options. And then, of course, reference resolving. But in the general sense, I think it's like 150 lines of code, and then you have a working parser in, for example, here in Python, without having to write that much code beyond that. So that's basically what we've been working on. And I took Python, and Suvik have Go, because the current Go implementation is not up to date at all with V3.
What did you use to generate the source code in Python?
Modelina.
I actually never used this project. Like, is it generally for creating source code programmatically, or what is it about?
Modelina?
Yes. IPA generating. Okay.
So Modelina was basically built for us to generate payload representations within an async API document. But those payload representations, because we abstracted the implementation layer, you are able to also just provide raw JSON schema documents. And that's the kind of logic that I'm using, basically. So all I'm saying is a few options. I say that I want to use a JSON serialization code, and then I'm basically just generating the code. This can be simplified a lot in the new version, because there's an underlying CLI that enables it. But for now, it's just a simple script.
Okay.
So it walks through all of the definition, like all of the JSON schema documents we have, and just generate the code.
Mm-hmm.
And then we sprinkle a little bit of custom implementation on top of it, without touching whatever is generated.
And is Java also supported by
Java,
this Modelina?
yes, Java is supported, and Kotlin is also supported, if I recall correctly. Yep. We also have Java, of course.
Okay. Interesting.
So that's what I've basically been working on. It's providing this one-to-one representation of the async API file with the underlying structure. There's still a bit that needs to be fine-tuned, but almost there.
I mean, does it make sense to basically the future do this for all the languages? Just to have the same models basically for every language?
Yep. Yeah, the idea was to figure out like the way that we got into this like process was we wanted to see how we could scale parsers across multiple languages and still make them maintainable long term without it requiring a bunch of people.
Mhm. Did you say something how it works in Go? Like, was it as easy as for Python, or are there, for example, more problems with Go already?
The problems that are rising is generally unions, tuples, and serializing and deserializing those data structures. Because in Go, for example, you don't have the natural union. And even if you then have a class or a struct representing a union, then you still need custom serialization and deserialization code.
You mean this or, right? You have message or any of message, for example.
For
Okay.
example, yeah, message or reference, for example, just those two.
Yeah, now I remember for Java, then you have to use just object. I'm not sure if it also would work for Go. And then I think the general data structure would be like a dictionary or map to model really general objects that could actually be a union.
The nice thing about using it like this is once we fix those problems in Modelina, it also means that once you give Modelina an async API document, it will generate more accurate payload models as well. So like everything is like this positive feedback loop, basically. So it's going to be interesting to see how it scales and long term.
I guess you have the general problems if you want to map everything that JSON schemas represent into every language, right? Because languages have the limitations a little bit. But it makes sense to improve this a little bit, and it would be easy to build parsers. Yeah, I think it looks really nice. On a good track there.
Yeah, so far I'm pretty happy with the approach. It is a bit like when you encounter a problem, especially since someone else is generating the code, it takes a little bit of finesse to like debug everything. But once you get into the flow, I think it's a good one. Especially since if the JSON schema files changes, you can just generate a new bunch of models, and then you can do that within 2 minutes. Not even 10 seconds. But yeah, that's what we are working on. Any questions or for that?
Nope.
All right. I don't have anything else for today, I don't think. Does any of you have anything you want to bring up?
No, not really.
All right, easy meeting.
Yeah, I
Um,
prepare something for next time.
nice. Me and Suvik wanted to do a like more in-depth tutorial kind of thing that kind of explains how we did these partial generations. But we just wanted everyone here when we did it. Now you got the quick and dirty introduction for it. But let's see if it makes sense to do it later as well.
You mean in the working group or something?
Yeah, in the
Like,
working group, yeah. Just so everyone knows what we're kind of working on and how it works, like on a high abstraction level, at least.
sounds
All
good.
right. Enjoy your evening, everyone,
Good.
and see you next time.
See you.
See ya.
Bye.